All right. I am going to solve an inclined plane problem, and hopefully, this can help you solve any inclined plane problem. So, here we go. We're going to use trigonometry and kinematics and Newton's second law to help us to solve this. So, let's go. We've got a 62 kilogram person on skis, and they're going down a hill sloped at 37 degrees. All right, so we've got a person skiing down a hill. Here's my little person on skis. So they're going down the hill this way. We've got 37 degrees here. And the question and so let's talk about what we know. What do we know? What are our givens? So we're given his mass is 62 kilograms. So mass equals 62 kilograms. Remember, kilograms is the unit of mass. It is not weight. They're on skis going downhill. Slope, we're given the angle is 37 degrees. We know the coefficient of friction is 0.15. And we are given time equals 5 seconds. Also, we can assume here that initial velocity VI is 0, because when they start skiing up here, they're not moving at all, so we'll say that is 0. Initial velocity is 0. Now, what do we not know? What are our unknowns? Well, we don't know acceleration, and we don't know final velocity after 5 seconds, VF. And we're going to use everything we've learned so far to figure those things out. Okay, so one thing we can do here is we can identify our forces. And one force that you should always automatically go to, because it's always there, no matter what, is gravity. So the skier's weight pointing straight down. All right. And how do we solve for gravity? What's the equation for gravity? So our first equation we can use is Fg equals mass times the acceleration of gravity. So we're just going to do 62 times 10. And that will be 620 newtons. 620 newtons. All right. Here we go. So that's 620 newtons going straight down, and that is gravity. I'm going to make sure we know. just a big G for gravity. There we go. Okay, so there is also the normal force, which will be perpendicular to the slope of the hill. So when gravity is on a flat ground, or when a object or person is on flat ground, the normal force will simply equal what gravity is, but not in this case because the normal force is now perpendicular to the slope of the hill. So it's not exactly going to be 620 newtons, but it will equal gravity. It will equal this component of gravity. There is a component of gravity going this way, and we can figure that out with trigonometry. And to make things easier with slope problems, one method that people always do is they tilt the inclined plane so that this part is 180 degrees, or it's flat. Before we do that, I just want to make sure we identify all our other forces. We've also got friction going this way, going the opposite direction of the skier, and it's parallel with the slope of the hill. And the net force, which I'll make a different color here, because everything in red is the individual forces, but all of these forces added up will end up we will end up with a net force going down the hill this way. This is the direction of the net force vector. All right, so all three of these forces added up will equal a vector that goes down the slope this way, and therefore the skier accelerates. All right, now I think we're ready to tilt our inclined plane. So let's go ahead and do that. All right, let me make sure everything's out of the way here. I'm going to clear. All right. And of course, if you're doing this on a piece of paper, you can just turn your piece of paper around. So here we go. Gonna make this relatively flat. All right. Let me erase some things so this isn't looking so confusing. So our 37 degrees is right here. All right. So let me fix our normal force so it's more perpendicular. All right. So now this is the slope of the hill and it's flat. And so our net force is in green. These are our individual forces. This is the normal force, which we don't know yet. Here's gravity, which is now going this way at an angle. And here is friction. All right. And the angle is still 32 degrees. Let me get rid of this guy. All right. And again, our skier is right there. Okay, so the normal force, this force right here, we don't know yet, but this normal force will be equal to this component of gravity, because gravity is going to have two other components that form a right triangle. And we can call that the y component, in this case, the up and down, or the y component of gravity, because on a graph, your y-axis, that's your vertical up and down axes. Get that out of the way. All right. So this right here will be equal and opposite to the normal force, this component of gravity. And there is an x component of gravity that will be parallel with the slope here. There's going to be gravity going, in this case, to the left, down, which is down the slope. Remember, we tilted the inclined plane so that the slope is flat. But remember, this is a slope. Gravity will be going that way, and it's parallel with the slope. And we can drag that down here, and we've got a right triangle. And if we have a right triangle, we can use trigonometry to figure out the lengths of all the different sides. We already know one side. Okay. And let me move this over here because now this is where that is literally what gravity is. Remember, if we tilt this back the right way, it would be straight down. But that is gravity, 620 newtons. And that is the hypotenuse of this right triangle we just made. Because right here is our right angle. All right. Now the question is, what is the angle here? If this angle is 37 degrees, this angle is also 37 degrees. Now you might be thinking, why? How in the world do we know that? Well, I can prove it to you. Okay, if this is 37 degrees, which it is because we're told that in the question, then, and remember, this is another right triangle over here. This part over here is another right triangle. So for this right triangle, we can know what this angle is. 37 degrees and 90, 37 plus 90 plus this angle should equal 180. And these two angles added up should equal 90. So 90 minus 37. And this angle here is 53. Now this line is perpendicular to the slope. And this angle from the slope to this line is 90 degrees. That's a right angle. So 90 minus 53 is 37. So this angle is also 37 degrees. And anytime you do an inclined plane problem and you form this right triangle to get the different components of gravity, this angle here will always equal the angle over here. All right, now we have enough information to solve this problem. We've got our angle, we've got one side of the triangle known, which is 620 newtons. Now we can figure out the different components. I'm going to figure out the y component of gravity, and I'll get what normal force is, because normal force will be equal and opposite to the y component of gravity. And once I've solved that, I can use Pythagorean theorem to solve for this x part of gravity, x component, which will be going down the slope. So let's label the different parts of the triangle, and I'm going to erase this green triangle so there's no confusion. All right. So this part of the triangle is our hypotenuse because it is directly across from the right angle of the triangle. So this is our hypotenuse. I'm just going to write H for hypotenuse. Here's our right angle. All right. The angle we're dealing with is right here, 37 degrees. And so this part is our adjacent, and this is our opposite. Now let's remember our next equation, we're going to use SOHCAHTOA to decide which trigonomic function we should use. SOHCAHTOA. And since we want to solve for the adjacent, which will equal will be equal and opposite to what the normal force is, we want to use a function that involves adjacent and hypotenuse because we know the hypotenuse. And that looks like we're going to use this one, cosine. So ca means cosine for C equals A over H. So the equation we will use, cosine theta, and theta is a symbol for angle, equals A over H. And we want to solve for A. We already know H. So what I'm going to do is I'm going to multiply this fraction by the denominator. And now H cancels. And you have to do the same thing to the other side of the equation. And now we have our final equation. Hypotenuse, or H, times the cosine of theta equals the adjacent side. All right. So I'm going to erase the H. And this is all the hypotenuse. And the hypotenuse happens to be gravity, right? So I'm going to rewrite this whole thing as cosine of 37 degrees times 620 newtons will equal the y component of gravity, which will be equal and opposite to normal. So we will know what the normal force is. Once we know the normal force, we can solve for friction. All right, so cosine of 37 degrees times 620. All right, so right now I'm just putting this into a calculator. You absolutely need a calculator with a sine, cosine, or tangent button. I'm using a Desmos scientific calculator, and I would show you, but then I would have to start this whole video over again because I forgot to check a certain setting that allows me to show multiple tabs. So just trust me, I'm using a calculator right now, and I'm doing cosine times 37 times 620, and I get an answer of 495 newtons. I'm rounding it. It's 495.15. I'm going to round this to 495 newtons. I rounded it. Okay, so 495 newtons is gravity going this way, and that is also the normal force in the opposite direction. So this is 495. This is 495 down here. Okay. Now I'm going to solve for friction, and I'm going to make a little adjustment to the vector I drew for friction because friction is going to be less than gravity going this way. So just to make it a little more accurate, a little more to scale, I'm just going to adjust my line here. It's going to be smaller than what gravity is because eventually this person is going to accelerate down the slope to the left. All right, draw my arrow. So that's friction. Okay. So for friction, I will use our equation for friction, F of F, force of friction, equals the normal force, which we just figured out, times the coefficient of friction. We are given the coefficient of friction, 0.15. So we will do 495 newtons times 0.15. I'm just going to punch that into a calculator. 495 times 0.15, and I'll get 74.25. I'm going to round that to 74.3 newtons. So this is 74.3 newtons. Now, to get my net force, I need to know what gravity is going this way. I will add these two up. I'm going to call this my negative direction. Usually right is positive, but I want to keep positive in the direction that the skier is going. So we're going to say this is positive and this is negative. All right, so 74.3 newtons going that way. What's gravity in the opposite direction? Well, we go back to our right triangle. And this time we know one leg of the triangle and we know the hypotenuse. We can use Pythagorean theorem to solve for this side. We could also do another trigonometric function. Either way, whatever makes you more comfortable. All right, so to do that, I'm going to use Pythagorean theorem. So my equation will be a squared plus b squared equals c squared. My a and b are these sides. I'll just say that this is a and this is b. All right, so a squared plus b squared equals c squared. And I want to solve for this side, so I'll call that b. So first I'm just going to rearrange this a little bit. I'm going to subtract a squared. Now this cancels, and I just move it over to this side. All right, and since that cancels, I'm just going to erase that. So b squared equals c squared minus a squared. And I'm going to take it a step further because I don't want b squared, I just want b. So the opposite of squaring something is square root. The square root of b squared will just be b. So I'll rewrite b. So any number squared, the square root of it is just the original number. And then I'll take the square root of c squared minus a squared. So b equals c squared minus a squared. And now I'm just going to plug in my numbers. So square root of 620 newtons minus square root of 495 newtons squared. It's important that you square it because we're squaring two numbers. So now I'm just going to punch that into a calculator. Square root of 620 squared minus 495 squared. You got to square them and then find the square root. And our answer here is going to be this equals 373.3. So I will round that to 373 newtons. 373 newtons. That's going to be my x component of gravity. Whew. Now we can find the net force. So the net force, let's see, the total net force. So these two will cancel out. So the net force is going to be 373. So F net equals 373 newtons minus 74.3 newtons. Get rid of this. So when you do that, you get your F net is equal to 298.7. I'm going to round that to 299. All right. Now we got our net force. Now we can get to the acceleration. Well, to get to acceleration, we can use this equation. Acceleration equals F net, which we just figured out, divided by the mass. All right, so I'm going to use a different color here for F net, for acceleration, I mean. So that's going to be 299, that's our F net, divided by the mass of the skier, which is 62 kilograms. And I'm going to get 4.82. I'll round that to 4.8. We'll say it's just 4.8 meters per second squared. That's our acceleration. We've solved one of our unknowns. Now we can use the acceleration to get the final velocity. Just gonna get my units in there. Meters per second squared. We're almost done. Now we got to use kinematics to solve for final velocity. All right. We've got a lot of math on here, so I'm going to erase some of our other work just to make room. Hopefully you've already written these notes down if you needed it. And you can always rewind to go back if you need to. All right, last part, we're going to use kinematics, and I'm going to look at my kinematics equations, and I'm going to see that probably the best and most efficient equation here is VF equals VI plus AT. Because we know time, we know acceleration now, we just figured it out. We know initial velocity is 0. We can solve for final velocity. So since initial velocity is 0, that's just gone. We don't need that. That's 0. So VF will simply be A times T. So 4.8 meters per second squared times 5 seconds. And we get 24. So after 5 seconds, this person's going 24 meters per second down the hill, which is pretty fast for a skier. 24 meters per second. So now our unknowns are solved. acceleration is 4.8 meters per second squared. Our velocity is 24 meters per second. If any part of this video confused you, please go back, rewind, and watch parts over again. Pause when you get confused. Slow it down when you need to. That's the beauty of this video. You can slow it down when you need to.